First of all, a very good evening to everyone. Before I begin, I would like to ask you all that have you ever wondered about how the universe was formed, how the earth came into existence, and how do planets move around? This was a doubt I had in my mind too during my childhood, and I am sure our students who are watching us now have the same thought going on in their heads. And if you all have such things in your mind, then don't worry, as today all your doubts will be answered, and this session will pique your curiosity to a greater height. So today, I, Sonia Buddhiraja, Principal at Shiri H.A. Gajera, English Medium School, Katargam, along with my co-host and Vice Principal, Mrs. Shweta Banerjee, welcome you all this evening for the webinar on behalf of Gajera Trust. The trust caters to more than 58,000 students in Gujarat, India, and serving the community has been a passion and fundamental reason why Gajera Trust exists. Now, moving on, I am sure this webinar will give you a fascinating experience and you will get to know about many interesting things. So today we have Ms. Parshati Patel on board with us on Gajera platform, who is our speaker for the day. And also, she is a great astrophysicist from Ontario, Canada. Now, without taking any more time, I would like Mrs. Shweta Banerjee to take over and introduce our speaker for this session, who will speak on the topic Life of Astrophysicist and Science Communicator. Over to you, Shweta ma'am.
Thank you, Sonia Madam. As your host for this evening, I have the great pleasure of introducing Dr. Pashati Patel. Dr. Pashati has done her PhD in astronomy and planetary science and exploration from Western University. She researched disks of dust and gas around young massive stars, which are a hotbed for planet formation. She has been communicating her passion for space science and technology with students and the public for more than 7 years. She works as an educational outreach and communications specialist at the Institute for Earth and Space Exploration, where she brings wonders of space to young scientists. She has also worked as a lead consultant and senior project manager supporting Canadian Space Agency's Junior Scientist campaign. In the Faculty of Education, Dr. Pashadi is an adjunct research professor at Western University. Since June 2019, she has been part of the Principal Scientific Advisors Consultative Group to the Government of India. Also, Pashati recently fell in love with night sky photography and uses her photographs to start conversations about different topics related to space and universe. Today, she is going to talk about life of an astrophysicist and science communicator and thus introduce us with her life and goals. Pashati, over to you now.
Thank you. Thank you very much for the introduction. I am really excited to be here today. I'm born and brought up in India, and so I will share my journey today, what I did as an astrophysicist, what I currently do as a science communicator, and how my training for astrophysics has actually helped me in my current role. I call myself stellar detective a lot of the times. And one of the reasons is that when I was young, I really loved searching for mysteries, whether it was watching CID or, just finding new things to learn about. And so studying astronomy is very much like being a detective because you are trying to find clues of how universe formed, how stars formed, how things move in the night sky. And using a lot of tools that we now have with so much technology, we're actually able to figure out all of these by just sitting here on earth. And so I'll take you through the journey of, how I came about, what kind of tools I used, what kind of mysteries I was able to solve, and how I share my passion nowadays. And it's actually a career which no one actually thinks about. So let's get started. So I would want to start from where it all started. And so my inspiration actually came from the fact that I actually visited Mumbai when I was very young in my teenage years. And I visited a Nehru Planetarium in Mumbai. And when I did visit, I had a lot of questions. I asked, how do these stars form? We see them in night sky. And I had a lot of these questions that my parents could not answer. And so what they did was what a lot of parents do is buy books. And so they ended up buying books for me. And tons of those. And I got very, very curious how the universe around us is. I was brought up in Ahmedabad, and I did not actually see the Milky Way galaxy until I went to the planetarium or with my naked eye when I was here in Canada. So it brought a lot of questions for me, and I really wanted to be the one who solves all of those questions. Now, obviously, I know that it's not possible for one person to solve all the questions. But I did not decide that this is what I wanted to do as my career until my aunt here in Canada gifted me a telescope. It was a small telescope like the one that you're seeing on your screen, but it really allowed me to see the night sky with my own eyes, see the moon, Jupiter, Saturn. And that's ignited a passion in me saying, oh, like I could be doing this one day. And obviously, world is very different. We don't operate on small telescopes anymore. And I'll showcase I don't know, the kind of telescope I was able to use for my own research. But it was a dream that basically was fostered when I was young. Now, you may ask, what is astronomy? So astronomy is one of the oldest disciplines in science. And one of the reasons is because back, thousands of years ago, what people could really do was look at the stars and wonder what it is all about. Some of those people did actually end up just trying to understand what is happening with these stars. And so astronomy is a natural science that actually studies celestial objects and the phenomena around it. Obviously, all of these phenomena actually take place outside the Earth's atmosphere, but now we also sometimes study the Earth's atmosphere to understand atmospheres of other planets in our solar system and beyond. And during this presentation, I'll use the word space and astronomy interchangeably because people think astronomy is a very, very small domain, while space is a very big domain. However, I'll showcase that it's not really, it's all interconnected. And so when I talk about space, it's, or astronomy, I'm talking about everything you can think of, including Earth, because Earth is part of the solar system. So let's kind of go ahead and have a look, what is all of these celestial objects and phenomena. So let's first look at this amazing image from the Apollo era, where astronauts were able to look back at Earth. And, this was probably one of the first times when we really thought that, Earth is really part of the system. And, being on the moon allowed us to look back at Earth as a planet rather than just as a home that is very hard to imagine for people. And then, we have advanced so much in the last, decade and more that actually a couple decades, because, we have been able to send robots to other planets. And here's an example of Curiosity on Mars. And, we have recently actually in the last month sent not one, but 3 different kinds of robots to Mars, whether it's orbiter, lander, or rover. And, humans have come a long way in trying to understand just our own planetary system. And when I mean by planetary system, what I really mean is this image. We have our sun, which is the star, which is at the center of our solar system. And then we have the 4 rocky planets, Mercury, Venus, Earth, Mars. And then we have the 4 gas giants, Jupiter, Saturn, Uranus, and Neptune. Now, when I was in school, Pluto was a planet. It's not a planet anymore. Feel free to ask me why that's the case. But interestingly, our solar system has a lot more things than what you can see in this image. We have comets, we have asteroids, we have moons. So many of the planets in our solar system have moons. So there is so much more that we're trying to understand when it comes to our solar system. How did it form? What happened? How did these planets actually come into being? And so if you kind of step further back, we can ask a question, well, how did these stars form? Planets revolved around the stars. So we look at this. This is one of my favorite pictures. This is a picture of an Orion nebula. So if you have looked at the night sky and know the Orion constellation, this is the nebula in the constellation. Well, nebula is basically an area where you have lots of dust and gas. It's materials that actually makes the stars. And so all of these images that you are seeing, all of these, tiny, tiny images, I'll show you a better version a little bit in a few slides. These are stars that are actually currently forming that we're able to see using lovely telescopes that we have. Now, if we step more back, we are now looking at galaxies. These are cluster of billions of stars that are coming together into this gravitationally bound object called galaxies. And interestingly, we are part of a Milky Way galaxy. This is not a picture of a Milky Way galaxy, obviously, because we cannot be part of the galaxy and take pictures. But this is a similar galaxy to Milky Way. And you can see that a lot of these white dots that you're seeing on your screen are all stars that have formed and are basically shining their bright light. Now, if you keep going further back, you keep getting this. This is one of the famous images called Hubble Deep Field. Each of the dots on these screens, except the couple ones, which I'm going to point right here with my cursor, except a couple of those, ones that actually show this really nice lines, the rest are all galaxies. Each of the dot on the screen that you're seeing in that picture is a galaxy, which has millions and millions of stars in each of those galaxies. So you can imagine there are millions of galaxies, billions of stars, and so solar system is not alone. Okay, and when we talk about space, I kind of wanted to touch on a few things on like what is included in the word space. What do I mean by I'm an astrophysicist? Why not, a robotics person? Interestingly, you can say, space has a very wide umbrella. You can be working in robotics and you're part of space. You could be working in planetary science, that is studying other planets, and you're part of space industry or field. You can be a stellar astronomer, which is what I am, or stellar astrophysicist. It's interchangeable again. You can be studying astrochemistry, chemistry amongst the materials in and around the stars. You would be an astrochemist. You can be studying astrobiology. You can be studying how life could form on other planets, moons, or beyond our solar system, or even just simply try to understand how life forms here on Earth to be able to extrapolate on places that we know might be suitable for such kind of life. You can also be in space education, which is what the field I am in now, as well as you could be doing law and policy. This is one of the most upcoming field where you're trying to understand what are the rules and regulations around private industries going to moon and Mars and, placing satellites in the night sky. Another really upcoming field is space health and medicine. We send humans to the International Space Station and they feel so many different things in their body. So many different things happen because of microgravity. And we have scientists and doctors that try to understand why that's the case. So this field of space is pretty vast. You can be studying, you could be part of mission operations at ISRO or NASA or CSA and still be part of this industry where you could be studying stars and still be part of this field. So which is pretty neat that it actually spans in a very many different directions. So now that I have some time, I'm going to give you guys a peek on what what it was like to be an astronomer and what it is like to be a science communicator. So I'm going to start kind of from my research area because, I'm best to talk about what I did for my research. So let's get a little bit of a peek. A cycle of a research basically includes a very many different things. One of the most important things is you trying to find a mystery. This is why I called myself a stellar detective, because when I was looking for a place or a topic to study, I was looking for a mystery that no one had solved before, and looking for something that already had some work, but maybe not enough that people are trying to understand what the phenomena is. So in addition to finding a mystery, you look for whatever's available around you, data, other people who have worked on it, and then you decide, all right, this is the topic I want to study. What do I need? Well, most of the time in astronomy, you either find or obtain new data. And I'll show you how we have done that before. And once you have that, you basically process that data. And there's a lot of skills that you can actually develop to get to this place, like computer programming, that will help you process the data. And then based on the data what you have and your previous observations from other research, you can actually develop a theory and you can test it. And this cycle keeps going. While you're testing, you may find something new and you keep going. Okay, so let's try and find what it looks like. So to start off, I want to kind of bring everyone on the same page. Stars actually come in different flavors. They come in different kinds of masses and temperatures. And the reason for that is because there are, different sizes. So for our sun, it's actually a G-type star. There are a lot of these different types of stars that you're seeing, M, K, G, F, A, B, O. And as you see, as you go from left to right, they're increasing in size, but they're also increasing in the mass and temperature. So the more massive you are, the higher the surface temperature. But the most interesting thing is that the more massive they are, the faster they live their life. And so I was particularly interested in these O and B type stars because they were really massive. They live a short amount of life, but they're very interesting because they're very, very high temperature. And so their temperatures actually for any of the stars can range anywhere from 3,000 to around 30,000, 40,000 degrees on the surface. And they can range anywhere from 1/10 the mass of our sun to 60, 70 times the mass of our sun. So they can get really, really big. We are lucky to be around a star like the sun. Okay. So what I really wanted to study was, we're going back to that amazing image of the Orion Nebula. This is a region, your stellar nurseries, they're called, because this is the region where you have new stars that form. All the dust and gas that's required is actually in this particular region. And shock waves and the amount of energy has, what it really does is it gets all the material to actually come to a center, which actually basically pulls all the material and gravity does its work. And then you start getting what we called these protostellar objects, which are these tiny objects that you are seeing on your screen in these tiny boxes. And each of these dots that you are seeing are their own stars. If I were to zoom in, this is actually what it would look like. So on the right-hand side, on your screen, you have these different kinds of stars that are just forming, which is amazing because you see a large variety of these stars. You see some that actually have this amazing tail with them, some that have just a cloud of material, and then you have some that have basically nothing but just a slit. So there's a star forming right behind it, and we're not really able to see it because we're seeing it from the side. And so my research, what I really was interested was trying to study these stars that are behind these, thick wall of dust and gas that I'm not able to see the stars sitting here on Earth. So how am I actually going to try and study them? So if I were to, say this is what that star looks like. Now, this is not a real image. This is one of those ones which is not a real image. But if I were to travel in a rocket ship, go close to the star, this is what it would look like. Okay, so you can see that I'm not really seeing the star. I'm seeing a very bright light from it. I'm seeing all the dust around it in this donut shaped, but I'm not really seeing the star. So, if I were to cut this in half from the middle, this is what it would look like. You have a tiny star in the middle, okay? There's some gap because they're really, really, really hot stars. And so any dust around them would actually basically evaporate, okay? And then as you go further away, you start getting cooler and cooler. You get dust. These dust eventually forms into planets. Now, I really wanted to study this region between the star and the disk where it looks like there is nothing, but turns out there's a lot of gas there, which we're not really able to see with our own eyes. And so for that, I was actually able to use one of the biggest telescopes in the world, the Canada, France, Hawaii telescope in Hawaii. Now, I was really excited when my supervisor told me, oh, we're going to, do this Canada, France, Hawaii telescope so that you can get your data. I got really excited. I'm like, oh my God, I'm going to be able to go to the telescope, actually see it operate. Unfortunately, the way it works nowadays is that it's all computerized. Everything is, you have one astronomer who's basically a resident astronomer at the telescope, and they operate everything for you. So you have to compete for the time on these telescopes. And so, I had to write a proposal. Here are the stars I want to take images of, take these images and send it to me. However, there are only so many people actually get time on the telescope. I was one of the lucky ones to be able to get 4 hours on a telescope, and that's a lot of time to be able to get on a telescope. And one fine morning, I just get an email: your star was observed last night, and here's your data. I was excited, and I was like jumping in my chair when I did end up getting the data, because it was something I requested, and they took it on my request, and it was something that was going to help me study these young stars that are massive, and we're trying to understand how they're forming. And so what are they actually doing at the telescope? So they're just taking pictures like what we do with our cell phones or, with our cameras. What they're really doing is they're splitting the light that is coming from these stars. So you may have seen a rainbow. When it rains, you have the water droplets that actually act as a prism. So if you're going to take physics and go into undergrad, you will be doing a lot of these experiments in the lab where you'll be splitting the white light into many colors, just like how you see rainbow. And so we actually collect that kind of data from these stars. And what it really looks like is like this. So now we'll go back and look at all the different kinds of stars I showed you, that K and all the way to O, all of those small to big stars. If I were to take their picture of that rainbow light that we would get, this is what it would look like, okay? And you would see it goes from purple all the way to red, okay? But in those purple to red stream that you're seeing these lot of dark lines. What are those? Those are actually what we call absorption lines. And these lines actually act like fingerprints. Now, remember why I call myself a detective is because these lights basically that you're seeing, these streaks, they are a fingerprint of the elements. They are same for the same element across the universe. And so what it tells me that if I'm finding a fingerprint for hydrogen, which is what I'll show you, which it looks like right here where you see my cursor, the dark patch in the red on the top, oops, I will go back. That dark patch on the red, in the red on the top, that is actually where hydrogen actually can be seen. And so if I have that fingerprint, I know that that is what hydrogen looks like, then I know that material around the particular star has hydrogen in it. The same way you can actually detect a lot of elements in them. And examples of some of those are actually shown in this picture. So you can see at the bottom, you have things like calcium, iron, manganese, you have, helium, all of these different kinds of materials, and all you really need is light from these stars, okay? And so I was able to collect a lot of these lights from these telescopes. Now, what do I do with that? I have the light. I know that there is hydrogen in it, there's calcium, there's iron, all of these different elements. Now what, right? So luckily, we are advanced enough to have computers that actually can create these stars on the inside. So here is a picture of a computer model that I had access to that created the star. This picture is an actual picture from a computerized model of a star and its disk. So I'm trying to generate what a star would look like thousands of light years away in a computer using the similar light I'm seeing in the slide I showed you at last. And so what I do is I compare the observations that I get from the telescope to the observations I get from the computer. I compare the two and I see where my computational model or my computer model is lacking, being I'm seeing helium in this. Why am I not seeing helium in my star? Why am I seeing iron in my disk or material around my star? Why am I not seeing in this? And so based on what I see on the observations, I go and try to find a model that fits best to the observations to understand what that star is particularly doing. Now, it sounds very simple, but it is not, obviously, right? Computer models are complicated and it takes a long time to run them. When I was an astronomer, I basically ran around 8,000 models in 4 years to finish my PhD. And I was able to do that for 4 stars. And so you can imagine it's a very painstaking process. You have to be very patient when you're doing that. So to kind of summarize what a day would look like in my life as an astronomer, well, it starts with coding computer models. You definitely need coding skills when you're trying to, recreate these things in your computers because you're not able to go to them and actually check them out. You are cleaning, extracting, basically all of these data that you want to try and, compare to your computer models. You're doing a lot of that. And then you're writing a lot of these materials into papers because you want other astronomers to see this. You want them to know what you found, because if they're not going to know about it, they're not going to try and compare it to their work. When you do end up publishing a paper, you have so many people that read it and they try and compare it to their research. And people try and find new ways to do the same kind of research that I did. So for example, the model that I showed you in the back, let me go back and show it to you again. This particular model is a very simple model. There are other people across the world who are trying to create more complicated models based on the research that has been done that shows, all right, I was able to fit this particular model, for 4 stars. However, in my paper, I would mention there are these few things I was not able to fit in my model. I don't know how they fit well. Why aren't they fitting? What are the things that I could input in my code that would allow me to do that? And so what these astronomers would then do is, oh, hey, I have this idea. Maybe we can add this and try it. So they would make their own model, try it with the same data that I have published, and try and see if they're able to come up with the same results or even better results. And that is one of the very neat things about science, is that you do something and you write it into a paper, you tell it to the world, and you have other scientists trying to recreate the same data. And sometimes you find new things while doing that. In addition to that, a major part of my, astronomer life is to go to conferences where, again, instead of writing a paper, now I'm telling people, just like what I'm, sharing with you guys, I'm sharing with the colleagues around the world. What this allows is to get a verbal, a conversation with the fellow astronomers. You are, coming up with new ideas, you're brainstorming things that they may have issues with that you are able to solve. All of these, exchanging knowledge, because if you are working by yourself in science, you are very stuck. You are working generally in large collaborations. You're working with other fellow scientists. And one of the most interesting part is actually being able to bounce off ideas, other scientists, and asking them, what do you think? How do you think this thing could work? I'm stuck at this place. And people generally are very, very excited to share their thoughts and ideas. And sometimes you come up with new things just from a conversation. The other major part, and actually during my PhD, the first year and a half-ish, I actually spent reading papers. There is so much literature about the stars that I was studying that I literally had to spend that much time to just go through all of these papers. And we look at all of these papers and we're trying to understand what people already know. Again, the same thing that, I would do after I write my paper is share with other people. Other people have shared their work and their observations and their knowledge about these stars. And we try and spend a lot of time reading the papers that others have written. And then last but not the least, but probably one of the most important part of my astronomer life is to write proposals. In order for us to get data, we actually have to, make a point or a case to people who are basically, giving us time on these telescopes, convincing them why I need the data, why they should be giving me time. You can imagine these telescopes take a lot of money and time and personnel to run, so they don't really have time for everyone, and they only pick a very few proposals every year to be able to do research. And so, thousands of people apply, maybe hundreds of people get time on it. And so, one of the major part of an astronomer life is to write proposals for observing data. But then as you go further in your research, you do proposals and for funding your grant or funding your research, because if I need more people to work with me, if I need more people to help me do the research, then I will have to find ways to pay them. And in order to do that, again, you're writing a lot of grants. So, during your time as your master's and a PhD student, you actually get a lot of training in writing proposals and how to convince other people that this is a worthwhile job for them to offer you. So I hope I've shown you guys a glimpse of what it looks like to be an astronomer. I'm happy to answer any questions about that. But before I go, I really wanted to show what my life looks like now. So I finished my PhD around 4 years ago now. And since then, I have redirected myself into a career that generally people don't think about. So people think, oh, you're an astronomer. For the rest of your life, you're going to be doing research. Most of the time, it's right. A lot of people do that. However, when I was in my PhD, I actually found really exciting to talk to public about space and talk to students, talk to fellow, people in my community about how space is important in our daily life and how space has affected us in so many ways and how we need to know about it just because we're part of it. And so after my PhD, I was able to actually get a job working at a university, which is where I'm based right now, talking about space and talking about how space affects you. And so, people who do this are called science communicators. And this is one of the many careers you can have. You can have a career as a researcher, a college professor, where you're teaching. You could be, basically mentoring people, just doing, guiding research. You could be a research scientist at many locations. You could be science communicator. You could go into fields like data science or work at, places like ISRO, NASA, or CSA. And I chose the science communicator life because I loved sharing my passion, but I also love talking. And it is very strange because when I entered my master's and my PhD, I was not someone who would talk about my passion. I was very afraid and scared of going in front of people and talking. However, my passion for space is so great that when I did get an opportunity, I would like to share, no matter how scared I used to be about talking about space with people. So over time, I was able to build, my portfolio, my skills, my confidence to be able to go and talk to people. So I'll show you some examples of how I've done that in the past. I'll start with the bottom picture here. I very often talk to the media about things that happen in and around us. So for example, yesterday I was talking to a journalist about the meteor showers that are happening tonight and how people could actually go and see it. This other time on the top, I have a picture right here of me at Harbourfront in Toronto, where during summertime, there's one day where a lot of scientists are selected to go and stand and talk to people about their research. So I was talking to people who were actually coming to a literary festival. They weren't even there to look and, actually take in the science. But we were there to talk about science and why, what we do is amazing. I also get to go into a lot of classrooms and talk to a lot of students. And then I get one-off opportunities of working with astronauts. So here in this picture on the top right, I'm actually with a retired Canadian astronaut, Dr. Dave Williams. He holds the longest spacewalk time for Canada. And he actually wrote a children's book. And he wanted someone who would come in with a science background as a science consultant. And so on his children's book called Destination Space, I was actually able to do science consulting. So I cross-checked the science they had and made sure, the plans they were talking about and the distances and all of that was accurate. So it's a very interesting life of a science communicator because it ranges in many different ways. And when one of the most interesting things I currently do with my job is to actually develop these classroom workshops. So on the top left, you're seeing me actually training our to graduate students, but also working with students in developing these activities. So I'm using my knowledge that I've gathered in my master's and my PhD about space, and I'm using it to develop something that is more friendly to the target audience. So in this case, we have students. So I'm, creating activities for students that they can learn about meteorites, robotics, space robotics, or even things like planets and other stars. One of the other neat things I actually get to do is actually host a podcast. You can talk about space all the time, and nowadays podcasting is a big thing. So I lovingly get to host and co-produce a podcast called Western Worlds at my current job. I also got to develop a new program where kids would come to the camp 1 week in the summer, and they would get all things space, and it's called Space Explorers Program. But then I also like to do a lot of public events. So in this bottom center picture you're seeing, it's actually a picture from Gandhinagar. When I was there, a couple of years ago, I was able to talk to students about astronomy and different aspects of astronomy, as well as my research. And then I also get to host events at our observatory. So here at our university, we have an observatory that is open to public once a week during the summer, and we host these themed events every year, depending on the time of the year, and I get to host these. So in this particular picture, bottom right picture, you're seeing that I'm talking about Mars, because we had a Mars themed event that year, and I was talking to students about different features on Mars. So it's a very widespread and a very different role than an astrophysicist, but I'm using all that knowledge that I have gained during my master's and my PhD. Because believe it or not, all the skills that I applied as a researcher in astronomy actually applies very much to a life of a science communicator. So one of the major part of my job is to lead workshops and train other people, but also at the same time, I'm using the knowledge to develop these programs and activities. I'm organizing events, but I'm also conducting research and analysis, not only in astronomy, but also in education. Try to understand what people are liking, how are they liking, how are they taking all of that in. And then a lot of my job actually also entails writing a lot of funding grants, because in order to fund a lot of these activities, we have to convince other people why it's worthwhile. And as you may remember, I was emphasizing on proposals as for a life of an astronomer. And the reason for that was because I did a lot of proposals during my master's and my PhD that allowed me to now get proposals, proposals approved from the government and other agencies to be able to fund these things. And then one of the newest way of actually being able to do a lot of communications is actually online. So we do a lot of social media as well as promotions, and then actually manage a lot of staff members as well. So a lot of these skills that you gain as a science, as an astronomer, can actually transcend into many other careers that you can have. And it's not common for people to have, other careers. It's becoming more and more common now, because you are not really able to fund every person who's going into PhD. Not everyone is able to dedicate their 20, 30 years of life becoming a researcher. People like other things, and they're finding ways to connect to what they love, to what their skills are. And so in my case, I was able to do that using, science communication, where I can still talk about space, still know a lot about space, and read papers and try to understand the newest discoveries and translate there for people who are really interested in learning about these discoveries. And so I hope that this gives you a little bit of a background on what a life of a science communicator and an astronomer looks like. And I'm happy to take any questions you guys might have about both of those. And I'll stop right there, and I'll take any questions. Oh, I'm sorry, I'm unable to hear for some reason.
Hello?
Hi.
Yeah. We are now moving on with the questions of the viewers now. The first question is from Ankita Patel. She's asking us how often an astrophysicist deal with an astronaut.
Yeah, generally astrophysicists don't really deal with astronauts. You can have astronauts who are astrophysicists because generally an astrophysicist studies the critical physics part and the mathematics part, or like you can say the more scientific research of the astronomy field. So, for example, in my case, I was studying stars. I, as a science communicator, do have to do a lot with astronauts because I do work with them in many different ways. But as an astrophysicist, I would have hardly ever had a chance to work with them. I may have seen them at events or met with them at department events, but I wouldn't ever have had a chance to work with them. So I'm very lucky as a science communicator to have worked with astronauts. Oh, not able to hear it again.
We are now moving to the next question now. The next question is from Mr. Yeah, it is from Mr. Prakash Mehta. The question is, how often astrophysicists deal with an astronaut? We have already asked this question. Sorry, from
Right.
Mr. Shyam Verma. The next question is from Mr. Shyam Verma. You can see the question on the screen right now.
I'm not able to yet, but hopefully soon.
Yeah, sure. Don't know. The question is, um, sorry for this interruption.
That's fine.
Why it is not?
Shweta ma'am,
Yeah,
you can take
definitely, ma'am.
another
The
question.
next question is from yes, it is from Mrs. Vanita Devgania. It is how much competition is there in this field of
Yeah,
astrophysics?
that's a really great question. So recently, just because of the lot of popularity of the field, there's definitely a lot of competition. At least in the North American side of things, we have a lot more people who are graduating with PhDs than actually positions for them. And so a lot of this is one of the reasons why there have been alternative careers that people are being pursuing. There is, less competition in other parts of the world, but definitely North America and Europe are very saturated with astronomers or astrophysicists in many ways. But it doesn't really mean that people cannot do it. There are still a lot of places in India and abroad that you can work and get your degree and keep doing research in.
Okay. The next question is from Anila Gohil. What do I need to study to become astrophysicist?
That's a great question. So, something that I did not mention in my presentation, but I love to talk about is the kinds of skills I gained and the kinds of courses I took. So I actually took science in my grade 11 and 12 when I was in Gujarat, after which I did 2 years of physics at MG Science College in Ahmedabad. And then I transferred to University of Toronto, and I did my bachelor's in astronomy and physics. And one of the reasons why I took 2 courses was because I was not sure if I was going to make it into astronomy. And so I had physics as my backup, but we use a lot of physics and math. If you want to do astrophysics, that's particularly important for you to know mathematics and physics. And one of the things that I actually gained, which really helped me in my master's and my PhD, was a skill of coding, which, is very popular right now, but back 15 years ago, it was not something that I knew. And so I had to learn those skills. So, I would say math, physics, and computational skills is something what you need to become an astrophysicist.
So the next question is from Shashi Yadav. How can we enrich an enthusiast knowledge through schooling?
That's an amazing question. Thank you so much for asking. I love this question because I'm so much into education now. I think one thing you as an educator could do for students is provide them opportunities to learn new things. Put them in places where they may not be comfortable, but it's good to get out of the comfort zone once in a while and learn new things that you would never done before. So I would say as an educator, you can provide them with opportunities to meet scientists or meet, astronauts, meet people who they may once want to be in future, and they would learn from real life examples. So showcase them role models and fields that are generally not very well discussed in our society.
Yeah. Then Vanita Devgania is here. She is asking what are the best university to study astrophysics.
Okay, so in India, there are a lot of places. You have the Indian Institute of Astrophysics in Bangalore, you have IUCAA in Pune. Those are some of the most important places, and I've visited at least one of them. There are tons of places in and around India that you can actually do. Abroad, obviously, there are tons of places in North America. There are Ivy League schools like Harvard, you have UCLA, which is the University of California. Los Angeles, Santiago. In Canada, I think there are a few universities. I did my undergrad from University of Toronto, so I obviously would, vouch for them. I did my master's and my PhD from Western University. So, each country has a few universities that are very, very worse, depending on where you want to study. I'm happy to help. If you guys have any questions, you can reach out to me.
Yeah. Uh, the next question is from a space enthusiast. He is asking that is that true that NASA is going to land a rover at February 18, 2021?
Yes. So NASA actually just sent a rover called Perseverance towards Mars, and they're going to land it on Mars hopefully in February 2021. They have landed rovers before, and this is not their first time doing, but this is a very unique mission. Is because it is not only going to collect samples for scientists that will be part of a later mission that will come back to Earth, but also it includes a small helicopter that will be, doing basically rounds on itself on Mars. And so it's a very unique new rover that they have sent to Mars.
Okay. So I think his question has been answered. There is one more question, a concerned parent, Dipesh Lakhani. He is asking that are there any ongoing projects for children to get involved in? Or could you please kindly share any suggestions to get the children of age group of 10 to 12 to get information about such challenges?
Yeah, there are tons of actually projects that are called community science or citizen science projects that students can be involved. There is one particular one that I would really like to highlight. It's called Zoo Universe. If you just go and Google Zoo Universe, you will find tons of different space themed but also other themed projects that students could do by themselves. I'll give you an example of one of them. There is one called Galaxy Zoo on it. That particular project allows them to first understand what kind of different types of galaxies you can have, and then they are presented with pictures and you are asked to actually classify galaxies. This allows the student to understand different types of galaxy and how they form, but then also be part of the science where they're actually categorizing these particular kinds of galaxies. And believe it or not, people who have done this in past have actually had published papers with scientists saying that they have categorized these particular kinds of galaxies. So there are tons of those, and I would really suggest to go look up this universe one. There are also a lot of local astronomy clubs that you can join. These particular clubs actually allow you to get hands-on experience with telescope. There's an astronomy club in Ahmedabad that I was part of, that actually helped me understand what telescopes are and how to operate them. But also then in general, meet other people who know or may know something different about science or astronomy than what you do. So those are the two things I would say I would suggest, is to look up Zoo Universe and other citizen science projects, and then get in touch with a local astronomy club to just learn more about it.
Okay. Next question is from Patel Ronak. He is asking, what is the most rewarding part of being an astrophysicist?
Okay, this is a tricky question because there are different aspects of being an astrophysicist I like. Obviously, at the end of finishing a project, you know that you have found something that no one else has done before, which is a very satisfying, a feeling that you can have. But during the process, there are small things that really help. I think one of the things that I particularly like is I actually get to collaborate and learn from other people who are doing similar kind of research. So, I get to understand their research, they get to understand mine. So it's a part of research to ensure that you are other people are able to understand what you are doing and whether or not you're doing it right. So explaining other people also gives me that kind of satisfaction. Okay, I'm going in the right direction, I'm doing something that is correct. And then obviously when I get results, I'm the most excited because it's something that other people have not researched before or found.
Okay, we will move on to the next question now. Is there a parallel universe?
Oh, wow. That's a question we don't know the answer to yet. We're still trying to understand our universe that exists right now, and we're trying to figure out what existed before the Big Bang or what's going to happen after the universe, if it ever collapses in our lifetime, what's going to happen after. So we're still trying to figure that out. And the neat part about space is that there are so many things that we don't know, and it fascinates people more towards this particular field because of the fact that there are so many things like parallel universe that we don't yet understand or know about.
Okay, so Mr. Sham Verma is asking, does astrophysics have a future?
There is definitely a great future, and I'll tell you a few reasons why. 400 years ago was the first time we saw Jupiter through a telescope. Okay, we didn't know much about that before that. We knew it was a planet because a lot of people in the history have kind of studied, how objects move in the night sky. And now we're sitting here, I am basically on half around the world conversing with you, and that is happening because of satellites. And the satellites play an important role in our life. And the reason why they stay the way they do is because we understand the physics of how things work. Otherwise, they wouldn't be staying where they are and they would not be communicating with us. So a lot of the astrophysics and fields like physics and math, they're very pure science. They're basic things that take years and years to develop, sometimes decades to develop all of these theories. But when they do end up doing, their applications can transform the way we actually look at universe. And so, if we did not have the basic physics with us, we wouldn't have satellites right now to actually allow me to talk to you the way we do, or even operate cell phones or GPS system. All of these things are the result of the basic physics and astronomy that we understand of the universe. And so we will definitely keep trying to understand the universe more and more. And we're thankful that the governments see these fields as something that they should be investing in. And so particularly in India, we have amazing things like we have, LIGO India that is coming up. We have the small square kilometer array that's coming up. We're part of the 30-meter telescope. All of these new kinds of observatories that we're coming up with and we're investing money in are actually going to allow us to understand and study the universe more. So definitely there's a bright future for astrophysics because our government is investing in so many things, and we as citizens of the country actually have access to those kinds of observatories and data. And so future is bright. If you're looking to get into this field, it's definitely something you should be doing.
Now the next question is from the students. Alien are real or not?
Okay, I always get this question. So, I like to step back when we talk about aliens. When we talk about aliens, we're thinking of a life that may look like us. Thanks to movies, it has shown us that, aliens could be looking like humans or at least humanoid looking. But what are these aliens? Scientists like to call aliens things that is similar to Earth, the one kind of light that we know, and something that could be found at other places in the universe. And so, I start with the basic question. The only life we know is here on Earth. We don't know any other life in the universe. So if we were to go and find life in other places, let's say on Mars, on Titan, or other places in the universe, we are just looking at one sample. And a statistician will tell you that's a bad example of doing science, is just having one sample. And so, what I really like to talk about is how life actually originated here. We are here because we have the sun, it's warm enough, there's liquid water, and scientists like to figure out what are the conditions in which life formed. And then they go out and look for those conditions in other planets, in other planetary systems, and look for planets that can actually host this kind of life. Now, the next step, of thinking about it would be, well, we're made of material that is available in and around stars in the universe. So if we are made of carbon, we're carbon-based life, is there a possibility of other kinds of life, maybe made of silicon, maybe made of iron? We don't know, because we only have one example, and that is what we are. And so, it's a very hard, but a very interesting field of astrobiology where people try to answer their questions. To answer a question, real or not, we don't know. We don't know if life exists other than what we know here on Earth. That is another great area of research that a lot of astronomers or astrobiologists actually look into. So, yeah.
Okay. The next question is from Ketan Parmar. He is asking, how can Newton's third law of motion be related with astrophysics?
So Newton's third law of motion, or actually Newton's all laws, are basic physics that we use in everyday life here on Earth, and the same way to all the planets and all the motions that you see in and around the universe. So all the basic physics that we learn, this is why I started with a BSc in physics, because I knew that I needed the basic in physics, all the different kinds of laws and theories that have already been established, to study the kinds of stars and planets around these stars, because they follow the same motion. All the dust and gas that I was showing you follow the same motions that we see and have studied in and around our solar system. And so me as a scientist, I use that to apply, almost on everyday basis when I'm studying, because all of those basic physics still stay the same, even though I'm studying stars that are thousands and thousands of light years away from us.
Okay. Thank you, Pashati, for answering these all questions. Since we are running out of time, we will end our interactive session hereby. I request Sonia Madam.
I think there are many questions, but we are running short of time. So we really had a great session, and on behalf of Gajera Trust, I take this opportunity to thank Ms. Parshati Patel, who has spared her valuable time for us. We are really enlightened with your knowledge, and the session was really very informative. We are thankful to our trustees, Shri Chunni Bhai Gajera sir and Kinjal ma'am, for their motivation and support. I am also very grateful to all our viewers for your precious time. Also, we look forward to organize such more webinars with Ms. Parshati Patel in the near future if we get to do so. As we move to end of today's webinar, once again, thank you all for your wonderful contribution, and have a great evening ahead. And as Parshati Patel is in Canada, so for you,
Thank you
have a
so
great
much.
day ahead.
Thank you for having
Thank
me.
you very much. Yeah, it was really very, we had a great deal of knowledge.
Thank you for
Thank
having
you
me.
for
Thank you for
joining
having
us.
amazing
Thank you.
questions. I'm sorry I couldn't answer all of them, but I would love to answer them at some other point.
Sure, Pashati. Have a great day.
You too. Thank you.